Hello, this is chapter 6, video number 1. This is going to be over an introduction on discrete random variables. Now, before we get into different probability distributions, we're going to continue our work with probability in chapters 6 and 7, but we're going to be introduced to something called discrete random variables. And I'm going to go back to our Plinko example because this can be turned into a discrete random variable and we can describe this distribution. So for our discrete random variables, we need two separate things. First thing that we need, we're going to make this into a table, but we need two things. We first off need the quantitative values that we can get, our quantitative values, and we also need the probabilities of each of those. So looking at this, let's go ahead and write out our distribution. I'll go ahead and insert in a table, maybe. There we go, table. And 1, 2, 3, 4, 5. All right, I think we're going to be good. All right, so here is our table. First off, we need to figure out some way to call, something to call this distribution. And mathematicians are not very creative. I'm going to go ahead and just name this distribution. Let x, and usually we use capital letters, let x be equal to the amount 1 on each token. The amount 1 on each token. So we get our little token, or I guess it's a chip. I'll change it to a chip. We put our chip up here, it falls, and then it goes into one of these categories. Now, instead of repeatedly saying, find the probability that I won $100, find the probability that I won $500, I'm just going to let X stand for the amount 1 on each chip. All right, so X is what it's going to be called. Now I need to go ahead and type out all of the different possible values that I could have for this. So first possibility, I could earn, our lowest amount would be $0. Our next amount that we could win is $100. The next amount we could win would be $500. We also have $1,000. And then finally we have $10,000. Now, one thing that I do want to make clear here is that there are two different types that we could have, two different types of variables that we could have. This one is called a discrete random variable because there's only a set number of values that this could take on. We could only win 0, 100, 500, 1,000, and 10,000. However, there are certain things called continuous random variables, and that is when we have an infinite number of values. So a good example of a continuous variable, a continuous random variable that we could have would be height. We already discussed that example before. You don't jump from 4 feet to 4'1". You actually hit every single height in between those. All right, so now that we have all of our possible values, let's go ahead and calculate the probabilities of each of these. So first off, $0. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 possibilities, and 2 out of the 9 are worth $0. So I'm going to go ahead and put 2 over 9 for the probability of getting $0. Probability of getting 100 is the exact same thing. We have 2 out of 9. 500 is 2 out of 9. 1,000 is 2 out of 9. And then finally, the 10,000, there's only 1 out of 9 of those that is the 10,000. All right, and we have our discrete random variable, and we have this in a table. So a few things to note here. How I know that this is a valid distribution. Well, first off, all of our probabilities must add up to 1 or 100%. You could have these as decimals if you wanted to. However, these would be repeating. 2/9 is 0.222222 repeating. So I just left those as fractions. Other thing, our probabilities must be between 0 and 1. So I didn't include anything that has 0 probability in here because that is just ridiculous. I'm not going to put $250 in our distribution because it's impossible for us to get that. Same thing, if the probability was 100%, that's not much of a variable, it's a constant. It doesn't change, it's just the same all the time. So our probabilities must add up to 1 or 100%, so 1.00 or 100%. And finally, the probabilities must be between 0 and 1. All right, so overview. Discrete random variable. First off, this is discrete because it can only have a set number of values. These are the only possibilities that we could have. If this were to be a continuous, this would mean that we could win any quantity, including cents. There's an infinite number of values you could win. That is not the case here. You need to name your discrete random variable. I typically use X. We could very easily have changed that to a Y if we wanted to. There's really no rhyme or reason to the name. It's just a name. We have each of the distinct values, and then all of these do have to add up to 100%. So that is it for our intro to discrete random variables.